at systems that cross at one point, and that's my solution. We looked at a system that will have no solution, that's parallel lines. Parallel lines have no solution because they do not intersect. Now, what happens, or can a system have an infinite amount of solutions, and what's that going to look like? Well, I have two equations. I have x plus 2y equals 5, 2x plus 4y equals 20. And the first thing I need to do, I cannot tell if these lines are the same because they're not solved for y. I can't see if they have the same slope or the same y-intercept. So I need to solve for y. And I'm not going to go through the steps because we should already know how to do it. This one will be y equals negative 1/2 x plus 5 because I subtract x from both sides, divide by 2. Here I subtract 2x, divide by 4, and I still get negative 1/2 x plus 5. And guess what? When I solve for y, these are the same lines. So they're like right on top of each other because they're the same exact line. If I graph this one, it's the same as graphing the bottom one. So they're on top of each other. And how many times are they touching? Well, they're touching all the time. It's an infinite amount of times that they're touching. They're not crossed like this at a point. They're touching on top of each other like this. So this system right here, and let's write my system has an infinite amount of solutions because they are the same exact line and they're right on top of each other. Okay? So they have an infinite amount of solutions. The next thing we're going to look at is how do we determine if a given point is a solution to the system? And it's very simple. Okay? It takes us back to the beginning of school where we're substituting values and working them out. So I want to know, is 2 comma 3 a solution to the system of linear equations? Where did I get that from? And I don't know where my solutions went. Okay, where did I get this? Okay, I found it. I'm sorry, guys. That's a little pause. Here are the two equations. We have 3x plus 4y equals 18. Now, I do not want to redo this video because I have done this like 20 times already. Now, I want to know if 2 comma 3 is a solution to the system. So now I'm going to go back and I'm going to plug in, because if I substitute this value for x, this value for x, for this variable x, and this variable, this value for y for this variable y, it should give me 18. So let's look at it. I have 3. Do that another color. I have 3 times, instead of the x variable, I'm going to put the x value 2, plus 4 times the y value, which is 3, and see if it gives me 18. This is 6 plus 12, and 18 is equal to 18, so it works for this one. Now, in order to be a solution, we got to check the other one, because it can't just work for one, it has to work for both. So let's check the second one. I'm going to do this one right here. So 2 times 2 minus 3 has to equal 1. So I substitute the x variable with the x value, the y variable with the y value. Now I have 2 times 2 is 4, minus 3 equals 1. 4 minus 3 equals 1, and it works. So the ordered pair 2, 3 is a solution to my system. And that's how we determine if a point is a solution to a system.